Joining me. In this tutorial, we're going to learn how to fade a light emitting diode. So instead of just blinking it on and off, it's going to fade in and fade out, fade on and fade off, over and over and over. It looks really cool. Now, okay, I know that sounds pretty simple, but let me tell you what, you're going to learn a lot of stuff in this tutorial. First thing, you're going to learn analogWrite. That's going to show you how to manipulate your digital pins so that you can get output that you might typically think of as analog. And also we're going to learn about the if statement, which allows us to control when things happen. It's extremely powerful, and it's really bread and butter of all programming languages. So lots of stuff to cover. Let's go ahead and dive in. All you need for this tutorial is an Arduino board. I use an Arduino Uno, but you can use any Arduino clone or derivative that you like. However, I do recommend actually sticking with the Arduino brand for these tutorials, that we know we're on the same page. You're also going to need a 220 ohm resistor. That's going to be red, red, brown on the markings. You'll need a light emitting diode, doesn't matter what color. And then to attach the two together, you're going to need either a solderless breadboard or you're going to need a little alligator clip. Now to set up the circuit, all you have to do is take either end of your resistor and put it into pin 9 on your Arduino board. And then take the short end of your LED, the short leg there, that's the cathode, and put it into ground. And then connect the remaining two legs with that alligator clip, or conversely you could put them into a solderless breadboard. And then you can go ahead and plug your Arduino in. So go ahead and open up your Arduino IDE, and go to File, Examples, Basics, Fade. Alright, let's start taking a look at this sketch. Alright, so there's a couple big blocks of code. The first big block of code that I want to look at are the comments. Now it names what this function does. It talks about how to set up the circuit, and then it lets us know that the code is in the public domain so we can use it how we want. So there's the comments. Again, highly recommend reading the comments every time you're jumping into a new sketch. So the next block of code we come down to is where we declare and initialize variables. We've got 3 variables here. Alright, so we're moving up to more complicated programs. Usually there's just 1 or 2. Now we've got 3. Now they are all integers, which, those integers are pretty straightforward, so that keeps it nice. And they've got names that are very descriptive, which is an awesome thing. It makes me love them. So the first one is LED. It's equal to 9. So, well, what do we think that is? Well, guess what? It's the LED that we just hooked into pin 9. So we're referencing the pin number that we have our LED in. The next one is brightness. We've got set equal to 0, and notice how the comments on the side say this is how bright the LED is. So brightness is going to track for us the relative value of the brightness of the LED. And then the last variable is fade amount. That is set equal to 5. And again, if we read the comments there, it says how many points to fade the LED by. So fade amount is basically going to adjust the rate at which the LED fades on and off. So there is that block of code. So let's move on to the next block of code. That's void setup. So setup, again, it only runs once. It's used to set up the sketch. And if we look inside here, there's only one statement, and it's our old friend pin mode. Alright, so if you recall, pin mode takes 2 arguments. It wants to know a pin number, and then it wants to know what the mode of the pin is going to be, either input or output. This should be familiar to you. We haven't used it in a couple tutorials recently, but so just again, a quick reminder, it takes 2 variables. It takes 2 arguments. The first argument is what pin number. Here we've got LED, so that's pin 9, where our LED is attached to our Arduino board. And then the second argument is the mode. Do you want it to be an input or an output? Well, we are illuminating an LED. We want to apply voltage to this pin, so we want that pin to be an output. Alright, and that's all that goes on in setup. So before we jump into the loop function, let's go ahead and talk about the analogWrite function. Alright, so analogWrite is something you'll be using a lot, so it's important to get to understand. So first off, analogWrite has nothing to do with the analog pins on the Arduino. That was a little confusing for me at first. I thought, that's how you would write to your analog pins. But analogWrite, really what it does is it can it's used to invoke pulse width modulation. Okay, so pulse width modulation, which we'll talk about momentarily, basically allows you to adjust the power output of one of your digital pins. So you can use analogWrite on pins 3, 5, 6, 10, and 11 on most Arduino boards. And again, the board is marked on the digital pin that it can be used at. It takes two arguments. First, it takes the pin number. So that's the first argument you pass. So any one of those numbers that we just talked about. And then the next thing it takes is the value. So, well, what is this value? Well, this value is either 0 or it's 255 or it's somewhere there in between. And it is representative of the amount of voltage that's going to be output at that pin. So if you write 0, then ground voltage is going to be at that pin. And if you write 255, 5 volts is going to be written at that pin. And if you write anywhere in between there, then the amount of power output is going to be adjusted. Now, I use these words loosely because actually what we're doing is we're changing the duty cycle at that pin. So let's go ahead. I've got a schematic here. We'll pull this up and talk about duty cycle and pulse width modulation. So what is pulse width modulation? Well, all we do is we adjust the amount of time that 5 volts is being applied at the pin. So we're either going to have 5 volts or 0 volts, but we're going to adjust the frequency at which that voltage is applied. So let's look at this first graph up at the very top. You see we got 3 different graphs here. So the red line represents the timing, okay? And for now, just consider this arbitrary timing, okay? And the black line represents the voltage. So it's a voltage step that's being applied at the pin. So it's either 5 volts or 0 volts. There's no 3.3 volts being applied. Again, it's either 0 or it's 5. So it's going to step from 0 up to 5 and then 5 down to 0. Now, if you notice the first one, in a given time section, there's only 5 volts being applied 25% of the time. So that would be a 25% duty cycle. And in analogWrite, so remember we said the range was 0 to 255. If you divide 0 to 255 by 4, 25% of that would be 64. Okay, so if we do an analogWrite of 64, we're going to get roughly a 25% duty cycle. And you can see that 25% of this arbitrary time, that pin is high at 5 volts. Now, what if we did an analogWrite at 127? So now we look down at that next graph there. So we can see 50% of the time, 5 volts is going to be applied at the pin. The other 50% of the time, it's going to be 0. So this would be a half duty cycle, 50% duty cycle. And then what about a 75% duty cycle? Well, that'd be analogWrite 191. And then we've got 5 volts being applied 75% of the time, and 0 volts being applied the other 25% of the time in that given time period. All right, so if you have a 0 duty cycle, well, then basically you're writing the pin low, so you're not going to have you're not going to have 5 volts being applied at any point in time. And then if you write an analogWrite with 255, now you're setting the pin high, and it's going to be at 5 volts the entire time. So by adjusting the duty cycle, the on and off time of the voltage that's being applied, we can adjust the power that is being seen at that pin. Okay, so that's how it works. It's pretty cool. There's a lot more to it than my cheesy explanation, and there will be more about it to read in the further reading section. But for now, I think that's good enough for us to move on and do some cool stuff.